Kia ora tēnā tātou katoa. My name's Shane Clark. I'm the General Manager here at Neuralite, and welcome to webinar number 40-something. I'm not sure exactly which one this is, but we've done a few of these now. Today's topic is on re-roofing existing roofs. So obviously that's what we're going to be talking about, and we believe that the most economical and environmentally friendly roof is the roof you have right now. So luckily for you, I've got other people on the panel with me. I've got John Stallard, who started his career with a plumbing and drain fitting apprenticeship. Then he moved on to running his own roofing business for some time. He was the former technical director of waterproofing systems, current LBP and senior technical advisor for Neuralite. And fun fact about John is in his spare time, he likes to turn petrol into loud noises with his love for classic American muscle cars. Also got Stacey Nicol. She is our system partner and North Island specification manager for Dimond Roofing. In Stacey's spare time, she loves all things training and coaching people, telling people what to do. Welcome. Thank you very much. All right, just a quick rundown on the webinar. So this is set for about 30 minutes or so. We try and keep this interactive as possible. Use the Q&A function at the bottom. At the end of this, a survey will pop up if you want the NZIA CPD points, like all our webinars online. We'll run a couple of polls throughout the webinar to keep you interested. Get everybody's buy-in. Right, so the key message today, like I said, is that the most environmentally friendly and economical roof is the roof you have right now. So we're talking about re-roofing, make good what you've already got. We're going to talk about different types of re-roofing. We're going to have a bit of a focus on membrane types of re-roofs, and then we're going to talk about metal tray re-roofs, which is pretty exciting. We're going to talk about how the two actually interact and intersect with each other. We're then going to do a quick live demonstration outside showing a re-roof being put down, and we'll need your participation on that. We'll be running a poll on that. So, right, to kick us off, we just want to see who's in the room. What this does is help us pitch our message, make sure we've got the right things covered. So, Jen, if you just want to throw up the first poll and tell us who you are, select an option. It's multiple choice, and you can't get this one wrong, so have at it. All right, let's see who's who in the zoo. There you go. Excellent. All right, we'll just go to the first slide and I'll kick things off. Just a bit of a quick overview of what we're going to talk about today. So what we're going to obviously talk about is renewal options, and we're looking at a couple of options, which we're showing here is various membrane options. We've got a double layer torch on membrane overlay, single ply thermoplastic overlay, and then Stacey's going to kick in with the metal tray overlay. So John, we'll start with you. We'll just go to our first slide, and you tell us a little bit about this this case study. Really, I think probably the best way to get into it. Let's go to the next slide there, Jim. Thanks, mate.
So this is a school in Palmerston North, and it had a old existing, and the very first type of old existing tray roofing on it. And the architects were looking for a cost-effective solution for an existing curved metal tray roof, which had a fall of about 2 degrees, which would have minimal disruption to the school, and that proved to be the case. Our proposal was to do a roof overlay, which is lightweight. It's, I think, about 7.2 kilograms per metre square, and would be consentable, and it would be covered by the Neuralite code mark. And of course, it went through successfully for consent, and the architect was very happy about that. The roof overlay was cost effective in the saving of time, which you'll see later in what I'm talking about. There was no need for a building wrap, which the architect estimated to be worth about 60K. And the biggest saving was there was no need to remove the existing roof and replace it. So all in all, it was the best option. And so that's what they went with, and what you're looking at now.
Cool.
The system can...
Yeah, sorry, John, we'll just go to the next slide here, and you can sort of tell us what the build-up looks like.
Yeah. So when you're doing one of these tray roofs, you've actually got to clean the roof down really well. You've got to look for rust spots, and you've got to treat them with rust kill. You're looking at the H-grade polystyrene infills, and it needs to be H-grade for compression reasons. It's high density. And the ribs are normally 43 high, and so you make those infills 50 mil. So when you're screwing down and getting compression, nothing's going into the ribs. So the next thing above that is the vapor barrier, which is a self-stick bitumen based, and then on top of that is a 100 mil PR board, and that gave an R value, or provides an R value of 4.55. The thermal brake fixings are then fitted, standard without any wind uplift calculations is 8 per sheet, and they've got to penetrate, the screw's got to be 25 mil through the tray, and then what you can see there is the fleece back TPO, which is the latest technology in TPO. It has more fire retardants and UV stabilizers than any other TPO membrane in the market.
How's that TPO applied, John?
So on this job, we spray applied it. So we have Nurolite have a spray system, a canister, and it's very quick, and it provides an even amount of spray to the underside of the fleece and onto the PR board.
Oh, so that's an adhesive, right?
Yes, it's a contact adhesive, and the beauty of it is it's quicker than rolling it, and the application is more consistent.
Nice. So the next slide shows some what we call in progress shots. These ones don't normally make the website because they're in progress, but they do tell a story, don't they, John?
Yeah, they do. You can see the old tray roofing down there, and the white polystyrene infills coming across. You can see the PR board being laid out and how it's being laid out. And the thing about this job is the PR board did curve. There's no cuts being made to it. It actually made the 2-degree curve just from its natural state.
Seamlessly.
I think it's an excellent system. I was really pleased to be up there working on it and being around.
And just roughly, John, how old was the existing roof, mate? How long had it been in service for?
So the tray roof on this one is pre-Dimond 400. It's a forerunner of tray roofing. It's a very old one. Right. When we were putting them on, we used to button punch the ribs together to hold them rather than clip lock. And I estimate it to be something from around about 1969, early 70s.
Cool. So the next slide.
Yeah.
You got a bit of a before and after shot.
Yeah. So the roof lights were taken out and infilled, and they were infilled flush with the H-grade polystyrene height. The roof is 429 meters square, and this roof was installed in just 2.5 days, excluding the metal flashings. It blew the socks off the architects. Absolutely, they couldn't believe when they come up there and saw the roof was finished between visits. So that tells a story on its own in the cost saving. But I think the big thing to remember is the TPO, these fleece back TPO sheets are 30 meters long, they're 3 meters wide, and you can lay 90 square meters about every 40 minutes. So that's how quick it is to put that roof on.
I couldn't. And I guess it remained weathertight the whole way through, right?
Of course, yes. And you can get the TPO on and tape the laps and just keep laying if there's a weather bomb or anything coming. You just get the sheet on and you can peel the tapes off and weld afterwards.
Nice. Cheers for that, John. Well, that was a bit of an overview of the membrane install. Our next slide brings in Stacey, our system partner from Dimond. Welcome again. I guess the first thing for you, Stacey, what does DARS stand for? What is a DARS?
Yeah, thanks, Shane. So DARS is our Dimond Advanced Roofing Systems, or more specifically in this case, our Dimond Advanced Retrofit Systems. So we have 3 different systems that very similar to obviously Nurolite's build up. It's the idea that you can keep the existing roof, no need to pull it up, no need to displace your tenants, but you can upgrade your building in order to mitigate your condensation, to reach relevant R values, and build up from there. So we have 3 different systems. We have our Dimond Advanced vented, which you can see on the screen. Following that, we do have a non-vented, which is virtually identical but without the vented rails. And then we also have a standard post and rail, so Dimond Advanced standard using soft insulation.
Nice. And where would you use a vented over a non-vented? Like, are we just, what's the idea behind that?
Good question. So as you can see with this vented system, you've got that vented rail, which actually separates that top sheet from the base sheet. So it means that top sheet can move freely. With our non-vented system, you're fixing all the way through to the purlins. So it's a fully sealed system, which is great for your coastal regions. But once you get up to sheets around 25 metres in length, you're going to get too much thermal movement. So for that reason, you'd definitely opt for your larger projects. You'd be opting for that vented system. Across all 3 systems too, you can actually use a massive range of our profiles. So you can use trapezoidal, trough and tray. And we do also have our DD630, which is a really popular profile and unique to Dimond. It's a concealed clip system, and it's also made with our on-site roll former. So with that, we can produce sheet lengths of upwards of 100 metres. And obviously, if you've got that clip fixed, you're also not piercing that top sheet during installation as well. So it's just another guarantee that's exclusive to Dimond for water tightness.
They say a picture says 1,000 words. I think the next slide is a little bit of an animation. You're going to talk us through the build?
Yeah, absolutely. So obviously this is going to fix this base sheet, but we're imagining that it's the existing base sheet there. So we'll clean that off, patch seal it, and then this is a full peel and stick vapor barrier that goes on the base sheet there, followed by your Nuratherm PIR to the required thickness. And then we'll have a standard underlay in the system, followed by our vented rails. So as you'll see there, those vented rails have those little legs at the bottom and pre-screwed holes. So those first screws are going to fix down to the purlins and sit in those lower legs. And then your top sheet is just going to fix just to the top there. So again, allowing for that easy movement. Another benefit too is in 50 years, or maybe you want to change the aesthetics in 20 years, whatever the reason, you can pull off that top sheet and replace it again without affecting the rest of the system.
Yeah, no, I think it's a pretty special point. So that vented batten is actually structural, right?
Correct. Yep, and we can supply PS1 statements for that as well. So we've done all the appropriate testing.
Very cool. All right, and sort of a little bit of the next slide's a bit of a adaptation, I guess. It's a little bit different, so mixing and matching here.
Correct. So again, we've got our 3 systems that I mentioned, but on top of that, we're also trying to be as adaptable as possible to obviously meet your project needs. So you can actually see 2 different methods going on here that are used together, which we have used together on a couple of projects now. So down the bottom, John actually explained beautifully earlier, but we're obviously filling our pan. So that's our DD400 profile, and we're filling those troughs with pre-slitted PIR. And then obviously, not obvious. If you look really closely, you can actually see that PIR ever so slightly tapers. So when you're using long run roofing, we're generally talking about a 3-degree pitch and upwards. But in the case of a 2-degree pitch, we can actually use this tapered PIR to change it to that 3-degree as well.
Excellent. I think, just to reiterate that point, can't quite see it in the render, but there's a very subtle 1-degree fall in that additional insulation. So that gets to the long run metals magic point of 3 degrees, right? Sure. So this I guess this next slide, or this next render, is basically just to illustrate the harmony, if you like, between the 2 system partners and Neuralite. So obviously at some point metal roofs tend to go into a membrane gutter. So we have that solved. There's going to be no finger pointing. It's a nice and easy, seamless transition between one and the other. Stacey, got a bit of a case study on the next slide as to how that works.
Yes, yeah, definitely. So we've been doing, I guess, collaboration on projects for years, whether it be warm roof or not, obviously using your PIR and rock wool and also your membrane gutter. So this was the Hawke's Bay event and leisure, or sport and leisure centre, obviously in Hastings there. So this was using our Dimond Advanced vented system. It has our BB900 on our base sheet. It's then followed by your Nuratherm PIR, the DD630 top sheet that I spoke about, obviously a nice long sheet lengths there, and also the membrane gutter, which is pretty cool to see around there.
Nice. Yeah, so that membrane gutter from memory was also insulated as well. So we were able to continue the whole insulation envelope across the roof there. Yeah, keep those questions coming in, folks. There's a few there that's really good. Look, if we don't get a chance to answer all the questions, which we don't often do, everyone who's attended today will get sent a transcript of this whole webinar and a full sheet of the Q&As fully answered. So if we don't get to your question, just hang in there. We'll get it out there. Right, so we're going to go to our demonstration now. Be with us. We switch bits and pieces. Right, a moment. Okay. Right. Introducing Tweedledee and Tweedledum, get let loose with a gas gun. This is our demonstration. So here we've got an existing brown-built 400 profile. An older roof, let's just say it's done 40, 50 years. It's still in reasonably good condition, but we don't want to remove it. So the next step in the system would be to obviously spot prime any rust spots, fix any broken sheets, or go over any skylights, probably the easiest way to detail them. And then we would, in this case, we're going to use recycled PIR board for the infills into the troughs. Excuse me. So you see that sitting just slightly high of the existing seam. And then the next layer in the sandwich is a self-adhesive vapor blocker. So this is an aluminium foil bitumen backed self-adhesive foil vapor blocker. And what this does, it stops any moisture-laden air coming up from underneath and infiltrating that insulation layer. So as you can see, this is self-adhered. We're not having to use any additional tooling or anything like that. We're not using adhesives or any glues or anything like that, so we don't have to wait for anything to cure. And the next layer in the system is the selected insulation. In this case, it's 80mm PIR board, which gives us an overall, gives us an R value of about 3.67, the 80mm by itself. What we can do is we can actually calculate what the additional infills will give you and give you a total constructed R value, which in this case, I'm estimating off the top of my head, we're in about 4.5. So this insulation layer is mechanically fixed. We're not having to strike the purlins. We're just going to have to hit the existing metal tray. We're using thermally broken fasteners and then special screws that are designed to penetrate the metal and hold them there. So these are fixed at around about 4 to 5 fixings per square meter, depending on the wind zone. So for extra high or incredibly high wind zones, we can add more mechanical fixings. Wonderful. It's actually quite easy to screw those in, but these guys have a unique ability to make it quite difficult. That's fantastic. So the next layer in the system, again, is a self-adhesive base sheet. So this is a 3mm bitumen sheet, which again is self-adhered to the foil face of the PIR board. First layer in the system. So then the second layer in the system is a 4mm cap sheet. In this instance here, we're using the slate color. It's 4mm thick, has a mineral chip finish to it to protect us from UV and occasional foot traffic. Now this is actually torch applied to the previous base sheet. Like so. Safety first. Safety first. Looking for some gloves. Just the thing to remember, once we're at from this stage up, we do have the opportunity to select different finishes. It could be a single ply thermoplastic, could be the bitumen, or if the pitch is suitable, it could be a metal tray, long run type roofing. So while we are using an open flame to torch the cap sheet to the base sheet, the whole system is actually enveloped prior to any flame being used by the addition of the self-adhesive base sheet. Excellent. And there we have it. That's the final application of the cap sheet. Excellent. All right, we'll leave you guys there to finish that off. We're going to go inside and rip through some of this Q&A. Thank you, gents. All right, go back to our presenter mode. Here we are. All right, so we have 7 minutes left in theory. We're going to rip through some questions and answers. First one's for you, John. Can you remember what the fascia detail was for the school when the TPO came down over the fascia there?
So the curved roof overhung the wall, and the underside of the tray was the soffit. So what they did was they put a stringer in, created a soffit, they created a fascia on the end, and what we did was bring the PR board system with plywood, using plywood as we came over the fascia. So we came off the PR board once we moved over the school interior onto plywood to a drip edge with a 50 by 50 angle. And so we come over and finished on the angle. And then there was external spouting, which was 175 by 175, I think, from memory.
Yeah, nice.
And so that's how that was finished.
I think in the transcript we can probably drop a copy of a standard detail in there to make it nice and easy. Stacey, I've got a question here for you. What's your minimum falls for your long run roofing?
So that's 3 degrees generally. Obviously, that is still profile specific, but majority of our profiles are 3 degrees.
Nice. And I guess sort of commentary to that, John, what's your minimum falls for your membrane?
It's 1 in 100, which is 0.6 of a degree, and we're code marked for that. And that's very handy when you don't want to come down through the ceiling of your building.
Yes, yeah, no, absolutely. Here's a good question like this one. There's a sharp-eyed hunter here is seeing that in your build-up, Stacey, that the liner tray was upside down.
Nice. Yes. So that was our BB900. So that can be reversed run or standard. So I can't actually think off the top of my head what it is, but obviously you'll get a slightly wider pan versus rib. So you can flip it up for either aesthetics or also it holds our post and rail system better, obviously having the wider pan there as well.
And we love it from our perspective as well, that it gives us more flats to put the our insulation on as well.
Yeah, awesome.
Another one here. Some suppliers don't require a vapor control layer. Is your vapor control layer compulsory?
Correct. Both our vapor control layer and the underlay are compulsory as per MRM code of practice as well. And that's just obviously ensuring if any moisture could possibly get in. I mean, we've got a lot of different trades that are coming and putting penetrations in through that roof. If anything isn't sealed properly, obviously that underlay is just there to protect it, as was the vapor control layer fully protects and encloses the systems.
John, I've got a question here about, do you need to upgrade the existing structure to overlay it? Or I guess it's not always required, but
I would advocate for tray roofing to overlay them. It's the best system. It's cost effective, and you saw how quick in my comments earlier. 429 meters square in 2.5 days. Everything in, membrane on. That's got to save the clients some pretty serious money, I would think.
Yeah, no, absolutely. But quite a lightweight system, though, isn't it? We're not really affecting the structure too much.
No, it's 7.2 kg per square meter, so it's very light.
Cool. There's a question here just from our demonstration. I should be able to answer this one because I was there. The thermally broken screws, do they fix to the seam? No. So the thermally broken screws that we put in, they just fix into the pan or the flat, or it doesn't actually matter where they fix, but they fix right into the existing metal tray. They don't have to go through and strike the purlin or anything like that. So our wind uplift is calculated on that. So question here for you, possibly, John. Do you have options for existing membrane roofs?
Yes, we do. So we can actually, depending on the fault, if it's a very old Neuchatel roof or very old torch-on roof in the days when the building code didn't have 2-degree faults, we can use our tapered board system. And we can use our tapered board system, and we can choose whether it's 3PM or Nuratherm TPI.
This one. One about your long-run roofing here, Stace. What's your maximum roof spans for which sort of profiles? Is there a minimum max? Or?
Yeah, if you go onto our website, every profile is going to obviously have different spans. But on our website, we have all of the details and the span tables on our tech sheets. So depending on what profile, but like our BB900, again, depends on what access is going to be on the roof. But I think that can span up to like 2.5 meters.
Okay, nice. Just scanning through these questions. So with the how do I get this one out? So the questions around about fixing into the trough section rather than the ribs, and we are with the liner tray, we are fixing into the pans, not the ribs. Is that correct?
Yes. So the thermal break on 100 mil on that job went 60, and the screw was about 80, I think, and it's got to penetrate the tray by 25 mil. So right. That's important in the calculation, 25 mil, the same as with the plywood structure, 25 mil through.
There's actually another sort of additional question here around what does it look like underneath that sample we've just done. And I can't flip it up right now, but what you'll see is that screw that we've put in does penetrate that existing roof skin by about 25 millimeters. Do we need a primer for the self-adhesive base sheet to the PIR board? No, we don't. I'll answer the easy ones, eh? Yeah. Can we put PIR board over old corrugate roof, John?
Yes, we can. It would be bespoke and would have to be worked through with the Neuralite tech team, but it is possible and it can be done.
Okay. Excellent. Well, we are absolutely smack on for time. It's going really well. There are a lot more questions here. Some of them are kind of double ups, which is great. So what we'll do is in the transcript, we'll answer them. There's a few requests for details and stuff like that, so we can drop sketches and links into there. So we will get back to all of those. So what we talked about today was some existing roof overlay type systems. We talked about various membrane options. We talked about the Dimond offering with long run metal above 3 degrees. And then we talked about how the two systems can actually talk to each other. So you will run a metal roof into a membrane gutter. We covered that off. So that is us for today. There's a survey at the end of this for your end today CPD points. And that hopefully we just leave you with the key message that the most economical and environmentally friendly roof is the roof that you have right now. Thank you to my wonderful panelists and the audience. We'll see you on the next one. Ka kite.